You need to have a certain mindset to work on simulations. You have to be able to foresee an incredibly complex process, create the initial state of your sim, then press play and hope for the best. A huge part of this work is trial and error and waiting for the computer to calculate. But before you think that it's the computer that does all the work, it absolutely does not. Computers can run the simulation itself, but in order for it to be correct and fit the artistic design, an extortionate amount of time is needed to set up every single aspect of the simulation. Whenever you see something truly mind-blowing on screen, that is almost definitely made by Houdini. Houdini can do everything. And of course, that means it is as complex as a software can get, so we will hardly even scratch the surface. Houdini is a procedural, node-based program, which is fanciful. You can build your sim one piece at a time and change anything at any point, giving you full control over everything. Before importing the model, I'd separated the head from the handle as only the head will shatter. Finally, I turned it to an angle and transferred it to Houdini. Houdini looks a bit different from Maya. There is still a 3D viewport, but the real work is done in the node editor on the right. Once I imported both the handle and the head, I dropped down a merge node and merged them. The way it works is that whichever node has the blue flag on its right is the one we see in the viewport. This way, we can go up and down our node graph and see exactly what does what. To move the hammer, I added a transform node, then put down the ERBD material fracture node. Now the head is actually separated into many smaller pieces. A subdivide node smoothed out the mesh nicely, and here you can see the complexity of the system within the fracture node. I made a few small adjustments to fine-tune the shattering, and added some physics to the system, so we could actually drop it. The last thing we need is a ground for it to fall on, and bang! Here, I wasn't happy with the amount of debris I got, so I made some modifications to the ERBD fracture. This is a good example of the computer doing the calculations, but me doing the art design. Now that I was happy with the result, I cached the simulation. You can see the minutes it took to actually cache, and it's actually really fast. Caching is when we let the program run through the simulation and save what exactly happens for each frame. We do this for two reasons. First of all, as we are dealing with a sim, the program kind of guesstimates what happens on each frame, so depending on what we are doing, our sim might look slightly different each time we run it. This is not ideal if we are in the middle of rendering our sequence and it crashes and we have to start from the beginning because the new render won't match the first one. The second reason is that we can't just jump to frame 50 and see how it looks there, because the computer has to run the whole simulation up to that point to do that calculation, so we would have to wait for it to run the sim each time we want to scrub around the timeline. But when we cache out the sim, we create an external file for each frame, and when we jump there, it will load in that file, so it is always consistent and we can go back and forth. And there we go, I jumped to frame 109 and the frame loaded in no problem. That looks good enough. We're ready to add the lightning. To make the setup be a bit quicker, I added a sphere to be the stand-in for the hammer, then a plane on the floor. The resample node adds resolution to the lines so they can bend. It is pretty difficult to talk about Houdini without getting technical, because the whole point of Houdini is that it's technical. But essentially, I am creating animated noise that resembles electricity. Some code here, a few nodes there, and once again, I'm doing the art directing while the computer does the simulating. After the test render, it's time to replace the sphere with pieces of the hammer. This is how procedural work allows us to change anything we want. I swapped the sphere to the hammer and everything else will still work just fine. I made some adjustments, keyframed the lightning strikes, and ran another flipbook render. Let's see, the hammer is too light, the lightning goes through the floor, and the sim in general seems a bit weird. In other words, good enough to be rendered. And that is exactly what we will do in the next video, where we will set up the lights, camera and render layers that we can then composite together into the final shot